Welcome. This is the second video about histograms. In this video, we're going to make another histogram using the same data set as that one in video 1. And we're also going to look at a histogram from a newspaper article and just do some interpretation of it. So our first plan is to make a histogram with this data set that was scores of people in a stats class. So it's the same 20 numbers from the previous video. You can see that they're in order. The difference between this one and last video is our bin size is only going to be 5 in this one. So we're going to follow the same plan, which is to put the scores on the horizontal, but instead of just doing every 10, we'll leave room for steps of size 5. Thinking that makes it harder to not write it. So instead of going from 0 to 10, 10 to 20, and so on, our bins will have a smaller width. The bin size will be smaller. So the scores are over here. And on the vertical, we'll still count frequency. And you can note that in the previous video, the maximum frequency was 8. And now that we have a smaller bin size, that should accommodate the bars as well. So what we're going to do is find the bins to put these scores into. And the first bin will be the one that's from 40 to 45. It will contain just 1. So one way to denote that is by dividing the list of data. The next bin will be the one that contains both 66 and 67. That's the bin from 65 to 70 will contain 2. And the first boundary one that we're going to come across is 75. And so the question is 75 in the bin that goes from 70 to 75 or the one that goes from 75 to 80? And again, we just need to make a decision. Let's include the boundaries in the bin to the right and not on the ones to the left. So the 75 will fall in the 75 to 80 bin. So that will draw us a line there. And that will also imply that 80 falls in the bin to its right. So 80 won't be in the 75 to 80 bin, but the 80 to 85 bin. So that also puts in a line here. So from 70 to 75, we have a bin of size 1. That's the 72. And then we have 3 here, because we're not including the 80, because 80 goes in the 80 to 85. But 85 is not included. So we have another bar of size 3. This bar is going to be 5. We won't include the 95, but we will include the 90 in this next bar. And 2 for the end. So you can see a little bit more detail of the score distribution in this histogram than in the previous video. But you can still get the same feel that most of the scores are in the higher range. One thing we can do to check that our work was done correctly is to count up how many little boxes we filled in. Again, adding up the heights of all of the bars should equal the total number of scores. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we indeed have, or that's a check that we've probably done the correct thing. The heights of the bars equal the total number of scores, the sum of the heights of the bars. So now let's look at a histogram that was in an article called 3 months salary for an engagement ring. For most people, it's more like 2 weeks. And we can read from this histogram, we have some numerical variable, the cost of a ring, with values spread out along the horizontal, and then the total number of people, which we've been calling frequency, is measured on the vertical. What I like to do when I have a histogram is to make sure I understand what one individual bar is communicating. So I pick a bar that seems to be, just a good bar to kind of get a feel for what's going on. This one seems like a pretty good one. And say, this bar says that about 150 people, because that's how tall the bar is, bought a ring for between, and then we really need to figure out what the boundaries are. You can see this mark for 1,000 is 2 marks in, so that means each mark is worth 500, because it would have gone 0, 500, and then 1,000. So we are between where we're looking at our bar. This one's 2,000, so the one next to it is 1,500. Between 1,500 and 20,000. 2,000, which is 2,000. So now that you kind of have an idea about what one bar means, you can get a good picture for what the entire graph is trying to communicate. So now now that we've taken a peek or taken a good look at the chart itself, let's answer this first question. How do you estimate how many total people were in the survey? We can add up the height of each bar. And we don't know that exactly because unlike in our previous examples, there's a lot of people, right? It's hard to know exactly what that tallest bar is. Is that 260? Is it 261? You don't really know. But one thing you can do is estimate. And you can recognize that each segment of a bar accounts for 50 people. That's just the way that this graphic has been designed. We can we can add up the height of each bar to get the total number of people. Or estimate. And we can also, because we don't need to know exactly, it's just kind of an interpretation about how many people. There are at least, and let's count up how many segments we find, like full segments, 1, 2, 3, let's use a different color so we can see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's obviously a lot more than just 21 full bars. If, for instance, we grabbed this little piece and put it right here, we could get another full bar. But let's just get a lower estimate. It's not bad. And we counted 21. Oops, we're typing in orange. There are at least 21 full segments, or 21 times 50, which equals 21 times 50. 1,050 people. There's definitely more because we didn't count any of these bars because they were all partial bars. But mostly we're just trying to recognize how you could do that, how you could make that estimate. And then lastly, what is the bin size? We've already done this. The bin size is 500. Is $500. And the point of me putting this question here is we don't want to confuse that, like not 50 people. The bin size refers to the width of a bar where you're counting how many people fall within a certain range. So all these numbers that reference how many people, like on the vertical, you're saying, oh, okay, well, for any particular bar, it's a range of values that's going to be $500. So we said between $1,500 and $2,000. All right, that's it for this video. See you in the next one.